Okay. Good morning, everyone, and thank you so much for joining our In Space series. Today we have Dr. Shonraj with us. Dr. Shonraj is an optometrist, currently heads the clinical research at Remidio. He completed his graduate studies at Elite School of Optometry and did his PhD from University of Melbourne. He also holds a couple of postdoctoral fellowships from UC Berkeley and Delhi Prasad Institute, India. Before he joining Remidio, he has held various positions, including associate professor and was heading the optometry department at Manipal Academy of Higher Education. And also, he was working as associate professor at UGDX School of Technology, Hyderabad. He has vast experience in visual psychophysics, programming languages, including R, Python, and also academic teaching and clinical research. He has over 30 peer-reviewed publications to his credit. He has also received various national and international grants on specifically studies focusing on glaucoma diagnosis, eye movement research supported by Government of India specific to DSC Tide and SERB. So we welcome you, Dr. Shonraj, and thank you again for joining and accepting our invitation. Over to you.
Uh, Let me share my screen. Screen is visible. Okay. Let me get the pointer. Put it there. Okay. All right. Good morning, everyone. Thank you so much for joining for this talk on a Saturday morning. So I have given this talk. I have given this title to Gopi saying that how AI is transforming optometric practice. Then I realized after giving this, okay, I should have done how AI will transform optometry practice. I don't think AI has penetrated in any of our practices, but I'm pretty sure it will in future. Okay. So I am Shonraj. I work as the head of clinical research at Remidio Innovation Solutions. So I do have a conflict of interest disclosure here. I work with Remidio Innovation Solutions. Remidio focuses on AI-enabled portable and multimodal medical devices, right? Okay. Now, when I started doing this PowerPoint, before I start doing this PowerPoint, Gopi sent me all these questions. Okay, this is just a selected questions. Okay, there are like more questions like this. And I looked at these questions and then I thought, okay, how should I structure my talk? I mean, if you look at this question, it's like all variety of questions. There are questions like, should I include this in curriculum? There are questions like, what are the job opportunities? There are questions like, can machine learning do this? Can AI do this? So I don't know how to really structure this talk. So there are probably two ways I could have structured this talk. I can talk about various AI tools that can be used by optometrists, like ChatGPT, Genie AI, AI Scribe. There are many like that. There are, in fact, a good friend of mine once told me that she has found 104 websites like this, which are useful for optometry practice. I can go and talk about this. Is one way, or I can talk. What is this black box called AI? How is it works? What are its potentials? So I can talk about this fundamentals, right? I can make you understand what is in AI. And based on this, you can come up with what are its applications. Now, the applications of AI is unimaginable, guys. And then I will also give you some pointers of applications of AI in optometry and how this will transform the practice. I leave it to your imaginations. Okay, that's how I structured this talk. All right, let's dive in. Okay, so what is AI? AI is something. Let me just bring this up a little bit. Uh, okay, AI is something that is an algorithm which tries to mimic human intelligence. Okay, there is no standard definition per se for AI, but the general accepted definition is that if an algorithm which tries to mimic an human intelligence, then it is called an AI. Okay. Now, in this, machine learning is one of them. Deep learning is also one of them. Okay. And now let's look what is this means. Now, AI are basically can be categorized into three categories: weak AI, strong AI, and super AI. What you see in Iron Man, Jarvis trying to detect his heart rate and asking it to slow it down, all that are super AI. Where are we right now? We are only at weak AI. We are not even at strong AI. Okay. Strong researchers are trying really hard to reach that level, but we are not there. We are not there. We are in a very, very initial stages of AI. I do not think in our lifetime we will see this. In our lifetime, we may see this. This may not happen. That's my perspective, but it might change. Now, some of the examples of AI are Siri, Alexa, other your smart gadgets, self-driving cars, etc., etc. Right. Now, the difference between the usual approach and the AI is in algorithmic approach. You write a step-by-step instructions like do this, do this, do this. If you do this, do this, do this, that's the outcome. If you do this, do this, do this, that's the outcome. But in AI, it's usually the computer learns how to solve this problem. Okay. Now, in algorithmic approach, you give a solution to the problem. But in AI, the machine learns by itself to how to solve this problem. That's the main difference between these two. Okay. Now, why AI is so popular now? Because there are two reasons. A, we have a huge data now that was not available 10 years ago. And our computers got so powerful. Okay. There is something called parallel computing. Okay. Which came probably in 2011, 2012 started gaining popularity. And that's post that the AI boom. Okay. Before that, AI was there, but it's not that popular. Now, because of the high computation capacities, it is possible now. Okay. These are the main pros and cons. I'm not going into the detail. Okay. Now that's a general introduction. I'm going to talk about the AI. I want to spend like 5 minutes on that, on general introduction. Now, next I'm going to talk about is what is AI. Let's go into that. Let's try to tackle this, and I will try myself to make it simpler to explain this. Okay. Now, if you look at AI means both machine learning and deep learning. When I started my PhD in 2011, it is called machine learning. Okay. There is nothing called deep learning back then. I did something on a Bayesian algorithm, which is a machine learning technique to check visual fields. Okay. So let's first talk about what is the difference between machine learning and deep learning. And whenever we talk about AI now, all the applications that you see around you are all deep learning. Okay. We are not using machine learning techniques anymore. Maybe in some old computers, maybe in some old perimetries, for example, Sita uses a machine learning techniques, but not anymore. All your mobile phones, your chat GPT, everything uses deep learning techniques. Okay. All right. So let's look at what is machine learning first. Let's jump into the problem. Okay. Now, here is the thing. We have a data set here. Correct. Now, what's this data set? Imagine there is a big data set. I'm just showing 10 examples here. These are patients. I have age here, the gender here, the IOP, the HVF, and OCT status. Based upon that, we make a diagnosis. Right? I'm sorry, guys. I'm a glaucoma person, so I'm going to bring a lot of glaucoma examples here. But I will try to give a little bit of myopia examples and things like that because everybody is crazy about myopia. Anyway, so let's talk about this bit. So you have a data here. How do you make a diagnosis? How a clinician makes a diagnosis? The IOP is high. Glaucoma hemifield test is outside normal limits. And RNFL is thin, then you call that diagnosis as glaucoma, correct? If IOP is normal, GST is borderline, but RNFL is thin or RNFL is also borderline, then you put them under suspect group, correct? That's all you do. Now, we let the machine to learn it and then ask it to predict it. Okay, that is the problem we are trying to solve. Now, in the machine learning terms, I'm going to introduce few terminologies. Please follow with me. Now, while feeding this data to the machine, we always feed the data individual rows as a individual records. Okay, meaning each patient data, we put it as record row wise, and the patient's features or the patient's characteristics, we put it in column wise. So in a machine learning terms, these individual things are just called rows or records. Okay. Now these are the patient features. These are the patient features, right? Now, meaning patient characteristics. Now these are called in machine learning terms as simple as columns or features or variables or independent variables or dimensions. Okay. I'm going to call this as variables or features throughout this talk. Okay. What I am going to predict, I'm going to give this patient features or variables to a machine, and I ask the machine to predict this. This is the predicted variable. This is the predicted variable. This is what I want it to predict. So this is the target variable or class variable or dependent variable. So I'm going to use the word, these are variables, and throughout the talk, I'm going to use the term target variable. So we input the variables into the machine and we ask it to predict the target variable. That's a problem. That's a problem we are trying to solve here, right? Now, if you look at it, this particular patient had 10 rows, or this particular data set has 10 rows, 6 columns, excluding the target column, correct? That's the problem. Okay, now what we do is we give this data set to a machine. Okay, give this data set to a machine. We ask that machine to learn by itself. Now, the machine might try to fit an equation. In a machine learning terms, the machine might try to fit an equation like that. Okay, it looks scary, but it's not really. Okay, what it tried to predict is it want to predict what is the diagnosis based upon the X here or the features or the variables. So depending upon the variables that we input, it is trying to predict the target variable. What is the target variable? It is going to be there. Now the equation I showed here is linearly adding this variables, correct? It is just linearly adding the variables. So it might come up with an equation like this. You know, a diagnosis is equal to some weightage of your IOP times some weightage of your Humphrey visual field test or glaucoma hemifield test times some weightage of your RNFL thickness. Correct? Now, this might come up, the machine might come up with an equation like this. And these are very linear equations, what I am trying to show here. And the equation may look like something like this. Okay. So what we do, we input the IOP here. We input the glaucoma hemifield test output here. And then we input the RNFL thickness here. So it multiplies by these numbers. I'm going to call these numbers W here as weights. So it's going to multiply this by these weights and has some bias added to it. And based upon these weights and bias, this would be the diagnosis. You see that in machine learning, we are coming up with a mathematical, most of the time. When I say most of the time, like 99% of the time, in machine learning technique, we will try to come up with a mathematical way to explain how the target variable is achieved based upon the variables that we input. Okay. Now, the equation need not to be a linear equation like that. It can be something like this, or it can be something like this, as complicated as this. It can go, the complexity can increase, but eventually I'm trying to explain this in a mathematical equations. Okay. Now, that's a very simple example. Now, what I do in a machine learning is I give a training data set, meaning I ask the machine to learn from this training data set. The machine comes up with an equation like that. Then that's the equation. Let's say it comes up from the training data set, and I ask it to predict on a testing data set. So I input a test data set. So where I do not give anything on the diagnosis. So in the training, the target class is already given. So the machine learns what should be the ideal equation for that. But in a testing data set, I do not give target class. That's what ideally we want to do it, right? When a patient comes in, we want to input an IOP value, HFA value, and OCT value to it, and it should automatically detect what should be my diagnosis. That's the main problem. That's what I'm trying to solve. So you give that, and it automatically predicts what is the target variable in it. So you have a training data set and a testing data set. So it predicts what is this, and we are good with that. Okay. Okay. So I'm not going to talk about unsupervised learning. Now, I give you an example of machine learning technique that is already there in our medicine field. Okay. Now, everybody aware about this study, Framingham study, where the major risk for heart disease comes from. We all know about this population. So while I'm going to talk, we all know about this particular study. What I'm going to really talk about is I'm going to show you the model they have come up with. Okay. So this is from the risk assessment score. Look at this. This is an online website they have developed. And based upon you, whatever you enter, your risk assessment comes up. So I enter my age, I'm 24 now. And then I enter my status. And then I make cholesterol level. So I'm just putting it slightly abnormally high to get the values right. Let's say I'm doing something. Oh, okay. The data available only for me. I put my real age. Okay, there you go. So it gives me the risk assessment. But if you look at really, look at that. It came up with a mathematical equation to do it. It has its weights and it has its bias based upon the input variable that we are trying to put in, and it trying to predict what is the target variable. In this case, the target variable is what is the risk. So this is the main way machine learning works. It comes up with a very mathematical equation for it to explain how things are working. Okay, this is great. This is machine learning. What is deep learning then? That's what we are using. Okay, I'm going to try to spend next 20 minutes on it, and this is a major chunk. Okay, right now, that's it. A deep learning, when I say a deep learning means it's a neural network. And what you see here is a neural network. That's it. That's the simplest neural network AI algorithm what you see. Okay, it might look very alien to you, but let me explain to you. All of us are coming from a biological background. We all know a neuron how it works. Okay, why it's called neural network? It is inspired from the neuron. We know how a neuron works. We have a neuron has a cell body. It has an axons and dendrites. Everybody is clear about it. Now, how this axons get stimulated? It may get input from another nerve. Not just from single nerve, but it may get input from multiple nerves. One nerve would try to excite it. Another signal might try to, inhibit it. Another signal might come to excite it. And we know if we receive this excitatory inhibitory signal, they basically does some mathematical operations on it. And then the output of this would be different. Let's say one is exciting, two are inhibiting, then probably this might be an inhibitor, act like an inhibitor neuron. Let's say two are exciting, one is inhibiting, then it might act like an excitatory neuron, right? So it receives signal and then it gives an output. Now, how much signal it comes from? So let's say the exhibitory neurons signals are very weak, but inhibitory neuron signals are very strong, then probably my output would be inhibitory, correct? So the signals, how much the signals, the weight of the signals that comes to me, based upon the weight of the signal, the neuron might fire or not fire. Also, the neuron might have its inbuilt ability to fire or not fire. Some neurons might fire with a small stimulation. Some neurons might need a lot of stimulation to fire. So it has an inbuilt bias to it. You see that the weights and bias comes here. The neuron also has what is the amount of weight of the signal that is coming to me, but I also have an inbuilt bias on it. Okay. So based on this, we can mathematically define this. Let's call this as a neuron. In a machine learning term, it's called perceptron. Okay, that's an individual perceptron. And I have many neurons connected to it, or many perceptron connects to it. Each perceptron comes with its individual weights. Each perceptron comes with its individual weights. And the cell itself has some bias. And based upon the weights and bias, it is going to activate. Are you guys with me? As simple as like that. Each upon its input signal and some bias, it is going to fire or not fire. Okay. So I have a neuron here. These are my inputs. These inputs will, each one will carry some weights. The neuron itself will have a bias, and based upon this, it will give an output. Correct? Now look at here. I have two inputs. I have three neurons. 1, 2, 3 neurons. And then I have an output. These are the weights coming from the neuron. So this input goes to this neuron connected by this much amount of weight. This input connected to this particular neuron by this much amount of weight. This input connected to this particular neuron by this amount of weight. And each one has different weights, the way it connects to. So this is probably exciting this more. This is not exciting that much to this particular neuron. And it has some bias in it. And it gets an output of it. All right. So if you start writing the equation of this, the equation of a single neuron would look like that. Let's not worry too much about the math here. But the general idea is you give an input much similar like our neural system. There is a brain behind it, which processes the informations and gives you the output. So far, good. Are you guys with me? Now, what is the, so that's the whole idea. So I have an input. I have a brain here, which acts like a neural and then gives me the output. Okay. Now, what does it mean? Well, here it is. Let's go back to the example previously. I give the input. What is the input for my previous example? In the previous model, I give IOP value, visual field index, and your OCT values. So we give these three as input. Okay. And we ask it to predict whether it's normal or glaucoma. That's it. So I give the input. Input here are my variables. My target is to output is to predict what is that, whether it is glaucoma or normal. Okay. Now, the main point I want to drive is, okay, let's not worry about too much about the equations about it. The main point I want to worry is for a single neuron. Here is an example of a single neuron. I have 3 inputs. The equation looks like that. The moment I put 2 neurons, the equation goes like that. The moment I put 3 neurons, the equation goes out of your mind. Very difficult to calculate. You know how many neurons or perceptrons a ChatGPT has? It has billion neurons. Okay. So you can imagine the complexity that it is dealing with. So it is mathematically not definable. Okay. It gets over your head. Very difficult to deal with it. Now, few of the names, architectures, I mean, few of the terminologies you need to familiar with. When I say architecture, this is an architecture. Okay. How many inputs are there in a model? How many neurons are there in the model? And what is the output? The neurons may be in single layer or it may be in 2 layers. Here you see 2 layers. That's the input. That's the output. It has 2 layers. And in each layer, there is 4 neurons there. Okay. When I call about architecture, the whole thing is called an architecture, neural network architecture. Okay. These are the weights. These are the weights. These are the weights. And these are the bias. Or in general, these 2 weights and bias are called coefficients. Okay. When I say model, again, architecture, model, pretty much the same thing. Layer, that's 1 layer. This has 2 layers. And much similar like your machine learning, it has a training set and a validation set. Okay. Now let's deal with one example. Maybe I'll spend a little bit time on this slide and then we can rush through. Okay. Here is an example which we saw with the machine learning model. I think everybody is clear on the machine learning model, how it works. But how it works on a neural network, how the neural network trains by itself. When I say it trains by itself, what it really means by the training. So let's start with this example. Simplest example we have we are inputting only three features here. You see that we are only inputting IOP, HVF, and OCT. Only three features or three variables in it. And we are trying to predict this target variable. So for ease of example, I'm just giving it three variables as input and one variable as an output. Okay. So here is the model we are taking. Okay. I have put in diagrammatically, it is only two variable. Ideally, it is three variable. I'm trying to put it as an input. Okay. I didn't get an example in the internet with three variable as input and one variable as output. And that's why it is put it like that. Okay. But for the example purpose, let's say we are putting it these three variables as the input. So what, and this is the target variable that we are trying to get it as a output. So far, good. All with me. All good. Okay. Now let's say, how do we train this model? Okay. For training, what we do is we first start with this training data set, and then we give individual patient data feed into the model. So we take first patient data. Okay. Now the first patient data has IOP of 28. Glaucoma hemifield test is outside normal limits. And OCT is really thin. So you take that and you feed this into this model. Okay. Now the model will have some weights and bias, and it will predict something. Let's say it predicted that this particular patient is normal. Let's say it predicted it to be normal. But we are in a training phase of the algorithm. We say that what you predicted, you guys, is wrong. You got it wrong. So we give a feedback to the network. Okay. What is a network? That's a network or architecture. Okay. We give a feedback to the network saying that you got it wrong, guy. Then what it does is it automatically, this is the part where it learns by itself. It automatically adjusts its weights and bias so that it gets it right. Now we didn't do it. We didn't tell you how much weight you should adjust, how much bias you should adjust to get it right. In machine learning, we do tell that. In artificial intelligence, we don't tell that. It learns from the data. All we give is a feedback saying that you got it right or wrong. It automatically adjusts this bias to get it right. Okay, once you got it right, okay, first data you got it right. Now let's start with the second data. We input the data, and the data, let's say get it right. We are good, no feedback is given. And then you again enter the third data. If it gets right, you don't give a feedback. If it gets wrong, you give a feedback saying that you got it wrong. So it automatically adjusts this weights and bias in the neural network to get it right. Okay. Now this particular way of giving a feedback and automatically adjusting the weights and bias is called back propagation. Okay. Now the back propagation is a big thing. It is actually invented by this guy called Jeffrey Hilton. Okay, he is called God of neural networks or God of artificial intelligence. Quickly Google it, him. You will find it. Okay, he is the guy who found out this back propagation technique. And from there, boom, it became a big success. Okay, so that's a basic idea about a neural network. I think I'm pretty clear. So we give this data, we ask this network to learn by itself. We keep on feeding this data until the network correctly predicts by some amount of accuracy. Let's say 98% accurate or 99% accurate. Once the training is done, that's it. You take this network. I take this network and give it to someone for using it. I can take this network, put it on your mobile. All you have to do is enter the patient IOP, HUF status, and OCT. Bingo, it will tell whether the patient is having glaucoma or not. Okay, so that's the main way by which neural network works. Now there are few more terminals. So if you think about it, the neural network here, it's much similar like how we think. So in our brain, let's say I give you the IOP status, glaucoma hemifield status, and RNFL status. What do? You process it in your brain and you say, hey, this guy is glaucoma, right? Much similar in the neural network. The network learns from the existing data. How do you learn? You see enough amount of, or you read enough amount of books. From that you learn. Which one is glaucoma, which one is not glaucoma. Same thing happens there. We give enough data and then we keep telling the feedback saying that whether it got it right or wrong. So it back propagates and it fine tunes its neurons, weights and bias to get it right. Okay. That's it. So, but unfortunately, this model, whatever we trained, is only trained to detect glaucoma. If you ask it to detect on AMD, it might not do it. So we are not there. It is not a general intelligence. Humans are general intelligence. This is not there. This is trained only to detect only glaucoma. That's it. It's a narrow intelligence. What we have is okay. So it's much similar like how our brain works. Okay, and it's in fact it is inspired from our visual cortex networks, and that's why it's called neural network. Anyway, so there are a few more terminologies I just want to touch upon. When we call about artificial intelligence, we talk about a neural network which has more just one or two layers. Okay, how many layers we have? How many inputs we have here? We have like 1, 2, 3, 4, 5. 5 inputs, 5 variables we give it as input, and there is 5 output, 4 outputs. Okay, this might be a case of where we give multiple images and we ask it to detect what is whether it is a cat, dog, horse, or bird, whatever it is. Okay. Um, if it has more than two layers, more than two hidden layers, it is called deep neural network. Okay. And whatever we use now is deep neural networks. And how many hidden layers most of the time a complex model has? It has thousands of hidden layers, guys. Okay. It has thousands of hidden layers. What we have is only 4 hidden layers is shown, but the hidden layers per se might be in the numbers of hundreds or it might be in the numbers of thousands. Okay. Depending upon the complexity. Now there is much similar like, so this is called ANN model, single layer. DNN, deep neural network, is more than single layer, more than 2 layers, hidden layers. There is also called a CNN, convolutional neural network. What it does is, in the slight difference, the only difference between your DNN model and a CNN model is only one thing. In DNN model, the input is variable. In CNN model, the input is an image. That's it. If an input is an image, then it is called CNN model. Okay. So I have a CNN model where the input is an image. The rest of the things are similar. There is slight change in the diagram. Don't worry about too much about it. The rest of the things are similar. I give an input and it has to predict whether it is a horse, zebra, or dog. That's it. Okay. I didn't go much into the math. I'm just giving the overall outline. So it's much similar like how our vision works. We give an input, it goes via multiple layers. It goes via multiple layers. Agree with me? And then, sorry, I give an input, it goes via multiple layers, and then we get an output in our perception saying that's a zebra. Same thing happens here. We give a zebra as input, it goes through multiple layers, and we get an output. Okay. What else we can do with it? We can do multiple things. We can do image segmentation. I can train a neural network. I will give enough number of DR cases, enough number of known diabetic retinopathy cases, and I train it to see how the diabetic retinopathy image would look like. Once I train it, all I have to do is I give the input. It will say whether the output is whether they have a diabetic retinopathy or not. Or I can give an image. Someone asked this question, can we do image segmentation? Yes. The older way of image segmentations using image processing algorithms is dead, literally dead. Okay. You can give an image and then you can say, you can train that network to say where is the optic disc. It automatically detects the optic disc. First time, it will put a circle somewhere else. Okay, not on the optic disc. Then we have to say, train to the algorithm saying that you got it wrong. The optic disc is actually looks like this. So it back propagates and it learns by itself. And if you do with enough data set, when I say enough data set, I'm talking about thousands of images or sometimes close to lakh images. If you train it with enough data set, next time you give the image, it will automatically do the image segmentation. In this case, it is detecting the optic disc. Or I can give an image, I can ask it to make it color image. You see a lot of mobile applications nowadays where you upload a black and white picture, get a color picture out of it. You can do voice to text. You can give a voice. Voice is your input. Okay. And the output is your text. You see that? And you train the neural network to do that. Similarly, one language to other language. Your input is in English, and let's say you want to predict in Tamil or Hindi. Okay. So all this is possible. Let me give some examples. Okay. Let me give some examples. For a computer, how the image would take as a computer. This is something I get the questions coming in. So how an image would look like for a computer? Well, For a computer, image would look like just like a pixels. That's it. So you take that and individual pixel values are entered as input. That's it. It has, you know that a color image has 3 channels, red, green, blue. So these channels inputs or your pixels becomes your input and your output is whether they have a diabetic retinopathy or not. As simple as like that. Okay. Now, little bit about what we do at Remidio. What we have at Remidio is we have a handheld fundus camera like that. A non-mid-reactive fundus camera, simple to use. All you do is point and shoot. You click an image and we have already trained a network to detect diabetic retinopathy. What we did with the network, we provided enough number of diabetic retinopathy cases and enough number of normal cases. So the network learned how the network diabetic retinopathy would look like, no diabetic retinopathy would look like, and then it will give an output whether it is a diabetic retinopathy or not. So all you do is you click a picture with a click of a button, it is going to give an output like that. So here is a video of that. Let me try to play it. It might not play. Oh, here it is.
With the Remidio fundus on phone, taking the best fundus images and screening for diabetic retinopathy has always been easy and quick. Now, with the help of AI, you can also screen for glaucoma. All you need to do is capture a disc-centered image for both eyes and click on glaucoma analysis. The images will be carefully analyzed for referable glaucoma and a vertical coupler-disc ratio measurement will be generated. Along with this information, the report will also highlight the abnormal areas. If you look here, you can see that the AI has picked up an early retinal nerve fiber layer defect that anyone could easily miss. Aside from standard procedure of analyzing vertical coupler-disc ratio, the AI also analyzes and highlights several key features that a specialist would look for during an optic disc exam. And the best part is that all of this works even when you're offline.
Right? So this particular example is an AI to detect glaucoma. We provided enough number of images how the glaucoma will look like, enough number of normal cases, so it learned by itself, right? And it highlights which region it actually picked up to be abnormal, okay? So that is also possible with this. So we have an algorithm right now to detect DR, AMD, and glaucoma. And my role or my team's role is we collect data for the AI development. We also validate this AI in a clinical settings. Okay, we have validated our AI in a multiple clinical settings. We got really good sensitivity and specificity of it. I'm not going in details, but that's for DR. This is for glaucoma, and this is for AMD. Okay. Now, somebody asked a question, can I do a saccade detection using an AI? Well, it can. All you can have to do is, we know that this is how the saccade would look like. That's a target and that's an eye position. This is an anti-saccade task, I presume. Well, it's written pro-saccade, but they have done an anti-saccade towards the other side and then they have come towards the target on the one side. So they made a saccade here. What should be my input here? If I want to do a saccade detection algorithm, my input is pretty much my raw values. I just feed in the raw numbers and I tell the AI where the fixation started, where the fixation ended. That's it. So the individual pixel values or individual eye position values becomes an input. All I have to tell is, this is where the saccade started, this is where the saccade ended. And the AI will learn by itself to detect the saccade. Next time, you just directly connect your eye tracker to the AI, and the AI will take the raw values, raw positions of your eyes as the input, and it will automatically say that, okay, this is the point where this guy did a saccade. This is the point where this guy did a pursuit. This is the point where he did a blink. Can be done. Pretty easy to do it, right? Myopia cases. What should be your input? Let's say I want to build a neural network to predict what is myopia or to predict whether myopia progress or not. What should be my input? How do I train the model? All I need to do is give the sum. This is some parameters. The parameters are up to you guys. The researchers decides this or a clinician decides this. You decide what is the current RX, what is your previous RX, what is your age, how much is the time you spend indoors, outdoors, what is your family history? Based on that, you can predict whether it can progress or not, right? You give the enough data based on which parameter they progressed. The machine learns by itself. The AI learns by itself. And the AI is going to give you the output. And next time, all you have to do is give this as input and predict what is the output is. All right? You can do multiple things. You can view which particular team wins IPL. It doesn't matter because CSK is going to win it. That's why I put output there as CSK. But you can do it. You can, what will be the inputs? You can put in each team how many match winners are there. What is the current form of the players? What is the number of all-rounders they have? What are the number of impact players they have? Whether the person they have Dhoni or not in the team, right? Now, this might sound crazy, but if you Google it, there is a guy who used a deep learning network to predict who will win the World Cup, football World Cup I'm talking about. Okay, it's there in the literature. Go ahead and Google it and then see. Okay, this is something everybody asks. ChatGPT, how does it work, sir? Well, ChatGPT, the network is exposed to various sources in the internet. Okay, the network is exposed to various sources in the internet. So the internet is actually its feedbacks. It learns from the internet. Okay. Now, what we do is, let's say I ask a question. Mr. Narendra Modi is a dash. What would ChatGPT will give? Prime Minister or Chaiwala? The most probable answer is the Prime Minister. How did it learn? It learned from the various sources out there in the internet. What is my input now? This is the input. Mr. Narendra Modi is a. Each word is my input. What is my output? PM of India. Each word is my output. Okay. ChatGPT works on this. Your words are your input. Your question is your input. The answer is your output. Okay. Now, if you look at AI as a tool, as a software, as medical devices, in the healthcare technology, radiology talks first. Ophthalmology comes somewhere. Where is it? Yeah. The number of FDA approved softwares are very less in ophthalmology, just 3. But this year alone, there is already 2 applications, and we are also going with a newer application. So this year alone, there is another 3 applications might come up. If you research or if you just Google how the AI is used in eye care, it can be used to detect cataract, conjunctival diseases. You know, you can use it for angle closure detection. You can use it for tear film abnormalities, cataract gradings, and things like that. Posterior segment, diabetic retinopathy, glaucoma, ROP, to detect glaucoma progression, use it in OCT images. And you can use it for segmentations to find out whether they have trust disease or not in ROP. You can use it for segmentations to detect or to put it in the different stages of diabetic retinopathy. All this is possible using artificial intelligence. Okay. Now I'm coming towards the end of the talk. Okay. I don't want to bore you more than that. But the burning question, what do you guys think? Will AI replace an optometrist? An optometrist. Mistake, grammar mistake. No? Okay. AI will not replace optometrists. Place the optometrist. What is the optometrist? Oh my God, too much grammatical error. Okay. But those who do not use the AI will be replaced. This is pretty much sure. Okay. This is something like, olden days when ATMs were introduced. Okay. One of good friend of mine, his dad is a teller in bank. He said his job is secured. He doesn't have to worry about ATM machines. Nowadays, there is no teller in a bank. Most of the bank do not have tellers. Okay. It's all ATM now. Much similar. If you do not use AI now, AI will not replace you guys, but you will be replaced. I mean, those who do not use AI will be replaced, right? Okay, anyhow, so if you want to learn more about AI, whatever I speak, a very simple YouTube tutorial is StatQuest. Okay, go ahead and then learn from this. This guy has already written a book as well. Pretty easy to go through the book, and he has simplified the concept to very basic level. So I strongly recommend you go and read it from this book. Let me take some questions, Gopi. I have highlighted the questions. I will try to answer it, and whatever questions comes up in Q&A, you can ask it later. There are a few questions I will take here. Is AI a threat to optometry? No, AI is not a threat. In future, we may have a retinoscopy which is built in AI. Think about it. Pretty simple. You take a retinoscopy, you scope it. It's an image that is coming to a retinoscopy. All we need to know is whether it is a with movement or against movement. And the AI can detect whether it is with or against, the output is with or against or neutralized. And we may have an AI-powered retinoscopy in very near future, right? Will image processing, image segmentation models, can it be worked? Yep, it can be worked. It is, oh, the next one is highlighted here. Sorry, I didn't see that. It is up there. What is the question? Oh, job opportunities. Okay. Well, there are right now the job opportunities is Remidio is one of the company which works on exclusively on AI. And in my team, I have in my office itself, there is like 12 optometrists. Okay. Now, most of us work towards AI. Okay. We do clinical validation of the AI. Once the model is trained, we take the model and then test it in the clinics. The research part, the testing part is with an optometrist. Also, for AI development, we need to collect data and give it to the AI team. That is also with us. And the AI team sometimes comes back and asks critical inputs. Should I do this? Is this disease detection is correct? Is this wrong? All that we also involved in the R&D part of it. So the opportunity for the AI is, the job opportunity for AI in optometry is booming. And there are already many existing, there are many opportunities coming up. And so in future, I see there is a huge rise in the job opportunity related to AI in optometry. Okay. Next question. Image processing, image segmentation. I already showed you an example. Okay. Glaucoma AI in our Remidio works on this basis. Can AI help you to set up in teleophthalmology? This is the future, guys. It might happen very soon where you don't even have to be physically present in front of the patients. Okay. An autorefractometer might automatically take the objective refraction and the subjective refraction, not based on fogging, but based on AI, it might automatically put in what should be the best corrected glass prescription for that patient. It might happen. It is very soon happening. I can promise you that. Okay. So you just take an, objective refraction. Somebody clicks that button there. The AI tells you what is the best corrected, best possible combination of sphere and cylinder that you need to put in for the patient. Forget about fogging. Forget about everything else. AI tells you that. Can you imagine it? Like, just makes our job much, much easier. Okay. All right. Do you think AI should be part of optometry curriculum? Well, I debate about it. Okay. I don't think it is, it's a bit too early to be there in optometry curriculum. But however, having said that, I still feel somewhere 4 to 6 hours of an optometry curriculum. I'm not talking in terms of credits here, guys. Okay, I'm talking in terms of hours. So if you can squeeze 4 to 6 hours of in a curriculum dedicated to AI, that would be great to start with. So the majority of the optometry colleges now have computer science as one of the credits subjects, right? You put in 4 to 6 hours in that as AI as a part. You need to know the fundamentals of the AI, but we are not there to put it as a separate curriculum or separate credit hours for AI in optometry. Can we measure saccades and pursuits? Next question. Yes, we can measure saccades and pursuits. I give you some examples there. Have you tried DALI? What do you guys think? I have tried DALI many times. ML models to detect systemic conditions through ocular examination. Yes, it is possible. We are working towards it at Remidio. There is a big science called oculomics. Search for yourself. Oculomics. Meaning, eye is the only place where you can see vasculature and nerve fiber layer, guys. So you can click a picture of an eye and detect systemic vasculature conditions like cardiovascular disease or coronary chronic kidney disease, or you can even detect Alzheimer's, Parkinson's. We are working towards that on that part. So it is possible to do that. What are the disadvantages? of AI transformations. Much similar like any other job, might make us lazy. But will AI, what are the disadvantages of AI? Like any technology, it might make us lazy. We may need not to learn with and against emotion in the future. We do not have to learn about fogging in the future. All that might be replaced by AI, but as any technology, with the technology, it might open a slightly different door for us. So what is that lie in us in future for us with the AI? I really don't know the answer. The possibilities are endless. Okay? It might open many doors. We don't know it. Okay. So that's it. I am not getting any more questions out of this. Okay. But I would like to take any live questions that has come into it from Gopi. If there is any,
Yeah,
I would like to.
yeah. There are a couple of questions. Like, thank you so much for this talk. Before I take up the questions, um, there is a question from Ms. Lata asking, we know that glaucoma progresses very slowly, and how we can decide in terms of output to decide whether the A can decide, okay, the further management has to be given or not.
So the
We
question
can
was,
look at the chat. Yeah,
I was just looking at the chart. A condition like
you
glaucoma
might.
may not
Yeah,
progress consistently. The output for right. I mean, it's already there, guys. I mean, why not you? Okay, so um, in glaucoma, you can input previous two visual fields data along with the OCT data. Okay. Now, researchers has worked on progression model. Previously, the progression models were on using more of a machine learning approach. But very recently, there are a couple of papers I can point it to it. They have done a model which can automatically predict AI-based model, which can predict whether the next field or the patient is what is the probability the patient is going to progress in next few months. Okay, so it's already there in the research field. There are a couple of publications on it. You guys can go and look at it. And it's just a matter of fact, this is getting implemented in any of the visual field machine or OCT machine.
the next question is from Beno. So he's asking whether do we have any data set like GitHub to pull in uh, maybe eye diseases in terms of fundus photographs
There are
and use
many.
that for.
Okay, so there are many. For example, if you take visual fields, there is Rotterdam data set. If you take eye images, there is IPAX data set. And most of the data sets are available in Kaggle. Okay. I don't know what is the reason for asking this. This is if you want to develop an AI algorithm for yourself, there are many open source data sets. Kaggle is the best place to start with and to download these data sets.
Okay, next question is from Ms. Ajita. Like, can AI be used without internet while integrating maybe with any assistive devices? I think she is pointing about low vision device. Maybe I don't know.
Absolutely, absolutely. I mean, think about it. We have an AI system at Remidio which doesn't require internet. Why? I trained the network, already trained the network in the internet, or I use a cloud computing basically to train it because I don't have a computational facility here. I use a bigger cloud computing facility to train the network. Now the network is trained. Once the network is trained, I can take this is in the training phase. Once it's trained, I can take it and I can put it in any device. It doesn't require any internet. Okay. The network can be put as an app here in your mobile phone. The network can be put in your mobile phone for the low vision devices. Okay. It can automatically read it for you. All that is possible. It doesn't require an internet connection. It is possible to do it offline. Majority of the companies doing it online for various reasons, for subscription models, subscription-based models, etc. But it is possible to integrate an offline AI in your mobile applications.
Okay. Couple of more questions. Like, what is the reason for having a false positive? Like, I think you were telling about how we have to give feedback and then it learns back again. So there is a question like if a
Any,
single, yeah, I think you can take it
yeah,
up.
any model will have false positives and false negatives. Okay. It's how much we train the model is what it matters. So if you train the model to have high sensitivity, the false negative cases is going to be less. If you train the model for high specificity, the false positive cases is going to be less. And guys know that very well, it is always a trade-off. So you train the model ideally to such a way that the sensitivity and specificity are nicely balanced. Okay. Having said that, an AI may give false positive and false negative results. Who is responsible for that? Well, right now, the person who is using it is responsible for that. Okay. AI is not an independent tool anyway right now. So let's say you are using it and you get a false negative response and you take a decision that, okay, I'm not going to send this patient to further treatment. That is your decision. AI is an assistive diagnosis for you. It is not a replacement for the diagnostic device.
Yeah. We will take couple of questions, last two questions. This is from Vivek. Can you please brief about how not to exploit AI in optometry?
What do you mean by that? I don't know the answer to this. Why not? Why not we should exploit AI in optometry? How not is not should not be the question. And my answer is
Right.
why not?
Yeah.
Let's exploit it and let's see it. What it's going to give it to us.
Yeah. And last question is like from again Dino. What kind of image he is looking for? Like how should be the pixel quality in terms of
Right.
lighting?
And it all depends. See, it all depends, right? Now, what is that output you're trying to predict? Are you going to trying to predict and so it's much similar like your fundus camera or your OCT device, guys. Like let's say if you want to predict a minute pathology, then you really need a high pixel image. It's just like how you're viewing it. Imagine that AI is just similar to your eyes, okay? And the AI is taking a decision out of it. So if you give a good quality image, it will pick up very minute subtle pathologies. If you don't, then it is not possible, right? So it all depends upon what is that you're trying to ask. There's also a question on, is there any affordable AI websites? Yes, there are.
Yes.
Go to AWS, Amazon Web Server, go to Azure, Microsoft Azure, go to Google GCP, Google Cloud Platforms. All this provide virtual machines which can be used for AI development. Okay, but that's on the development part. Why should we be worried about it? Okay, in future, okay, there is one more question I really like to answer. Do we need to know coding to learn AI? I was surprised nobody asked the question. I was expecting the question. Do we need to know coding to learn AI? The answer is no. The answer is no, not only to optometrists here. The answer is no, even to the software engineers we are saying now. We are moving towards a world where no code AI is where the future is. What is more important for us is to understand the fundamentals of the AI. There is already tools available in AWS where you put this as an input, you define the number of neurons, you define the number of layers, and you define what is the output activation functions and few more mathematical equations, and just click. That's it. It trains by itself. We do not need to know coding in future. Coding is going to be obsolete in future. Okay. This is very important, guys. So we can learn to do code AI development and optometrists can possibly do. We are moving towards something called as a federation models. I'm not explaining too much about it. Where an AI, now it is more generalized model, meaning we give data from everywhere. But in future, it is going to be a federation model, meaning AI data learns from your own practice. Now you have your own method of prescribing something for a patient, and that is not probably generalizable. So you can develop your own AI system for you to tell. So the federation models are the futures, and that's where we are heading, and we do not need coding to learn AI. Okay, and there are many people I know who teach fundamentals of AI for optometrists, and if you need, I can give contacts about that.
Yeah, we will take this last question.
Okay.
What is the medical legal implication if you find if you miss or misdiagnose a condition
Right.
using AI?
Right now it is with you. Right now it's with you. Okay. There are So the FDA defines that the person who is using AI is responsible for that. If if it is a resource constrained settings, okay, where there is no a healthcare profession available, then the AI is responsible, and it is depends upon what is the intended use that is put for the AI. Okay, but FDA clearly defines that it is the person who is using the AI, they are the responsible for any cases diagnosis that is made by AI.
Okay. So I think we have answered most of the questions, and due to the time limit, I think we'll close the session. I thank Dr. Shonraj for accepting our invitation and giving like a overall very quick and clear explanation. If any of you want to recap and listen to this, we will upload it soon in the our YouTube platform, and keep watching for more updates through us from our LinkedIn page as well as YouTube. Thank you again for joining, and thank you, Dr. Shonraj.
All right. Thank you. Thank you so much, guys. Bye bye.
Bye bye.